All right, so just make sure the slides are moving. Give you 2 seconds about us. So we are a small company based in Kitchener-Waterloo, and we're very passionate about the intersection of cloud, security, DevOps, and open source. And our mission is to digitally transform municipal IT using these concepts and technologies. So take things that are historically very non-cloud native and move them there for them. And we do that, we believe very firmly that security and cloud native can actually increase efficiency. There's this concept out there where you have to put a firewall in at the door, and that's a single entry item, and that's very non-cloud native. So that's kind of our strategy, is to rethink how security works so that it's throughout the system. My high-level strategy, and that's what's driven a lot of the technology decisions, is the first thing I look for is open source with active communities. So, there's a lot of things that are kind of open source, but there was one pull request last year, and I try not to get involved in that unless we're prepared to take it on as a maintainer. Otherwise we might look to open source something ourselves if there's no active community. That's one of the things I really like about the cloud native ecosystem. Generally speaking, each of the projects has people that are passionate about it, which means it drives very quickly. The second part of our strategy is everything has to run on Kubernetes. We don't run any pet sets. So things that you'll see in the next slide where we talk about relational databases, these are things that historically haven't run that great on Kubernetes, and we've sort of put our backs into making that work. We want everything to be cloud native, and by cloud native, I mean it's dynamically scaling in and out. It's accepting failures all the time. A big part of our strategy, all of our clusters, we use 100% preemptible nodes on Google Cloud, which means that the chaos monkey comes early and comes often for us. And we've designed our entire ecosystem to allow for that. We use Kustomize for 100% of our sort of operations, and we do that via GitOps. So things get checked into Git, and then we use Kustomize to do the deploy. We don't use Helm at all. We have one deploy directory per cluster, which means that 100% of the cluster is applied all at once in one step. There's no ability of someone to sort of edit one namespace or one deployment. We do secret management via SOPs. If you're not using Mozilla SOPs, I really recommend you take a look at it. It allows us to have our secrets stored in Git and be safe. So by secrets, I mean passwords and TLS keys and so on. A big part of my strategy is zero trust. So a lot of people have this sort of security model of outside bad, inside good, and they sort of run everything internally without TLS, and passwords are just in the clear. We assume that the internal is already compromised, and therefore we have to have security at each layer all the way through. And that's driven a decision around network policy, Istio, mutual TLS, etc. And the last part of our strategy is we self-host everything. So other than GKE, we don't use external services, like we don't use like Postgres as a service or something like that. Our basic architecture, we have two types of things. We have one singleton cluster we call our NOC, and then we have one cluster we call our hosting cluster, which is by geography close to our customers. And that one is multi-tenant. Within it, each customer gets a namespace. Kubernetes is not really designed in its security models for multi-tenancy, and that's a lot of the tooling we've put in. So the tools that we've used to do that, we use Envoy. We use Envoy quite a lot. We use it outside of Istio. We use it as a basis of our firewall. We're one of the contributors to it. We also use the Open Policy Agent, OPA. We use that for all of the API controls internal to our system. So rather than coding it in each API, in our open API spec, we express something, and then we use Rego and OPA to have it take effect. Everything within these clusters is all mutual TLS, courtesy of Istio. A couple of things I would call out from the CNCF ecosystem that we're pretty happy with. I'll talk more in the next slide, but we use TICV, or I'm not sure how you pronounce it, but the TIDB project's key value store. That solved one of the really key issues that we had. We put Titan on top of it, which gives us a cloud native Redis without having the traditional problems of Redis clustering. And then we use a lot of the same technologies that everyone else does, like Prometheus and Alert Manager and so on, Elasticsearch. And CockroachDB is one of the other heroes for us, which is a relational database that's very cloud native. So things that I would say that we do that are a little bit novel that I would share with the crowd. The first is we use FluentBit everywhere. So we don't use FluentD. And one of the things we do that's unique in FluentBit is each of those hosting clusters, they sweep up all their logs with it, they enrich it, they add the Kubernetes labels, etc. But then they use the Fluent forward mechanism to send it to our NOC, where it's received by FluentBit again, and then it's inserted into Elasticsearch, where we use our logging. And this is, I think, a little bit unique. It means that we don't have the traditional FluentBit to FluentD or other architectures. We use TLS client certificate authentication for that. We also use FluentBit as a gateway into Kafka and Druid. Our big data solution, our columnar store, is based on Druid, which unfortunately requires bringing in Kafka. That was one of our main challenges, was the sort of Kafka, Zookeeper, Druid, the Java components there were not very cloud native, and we had a lot of work to do to get it there. The Titan, so Titan is an application that sits on top of TickV, and it provides a Redis facade on that underlying shared out key value store. And it's really, really fantastic. It's intrinsically multi-tenant, so each sort of authentication key you log in with, it segments all the key value pairs by that. So you can run one copy for your entire cluster and scale it quite nicely. 100% of our APIs are based on OpenAPI 3. So we specify them in the OpenAPI 3 YAML, and then we use code generators to build our SDKs. We implement the code backend in Python. But something that's kind of unique here, a lot of people use OPA for their RBAC control on Kubernetes, but we also use it for our APIs. So it controls based on our JWTs who can do what for us. We have a custom use of Envoy. So we have our own build of Envoy with some things that we're still working on upstreaming. And that allows us to do very fine-grained role-based access control, including on the payload. So on behalf of our customers, sometimes they want only allow a post to this endpoint if the body is JSON and field A is equal to this value from the JWT. And another thing that I think is a little bit novel is CockroachDB. So CockroachDB is a Postgres-style database, but it's sort of shared nothing, or sorry, it's scaled out across your cluster. What we do is we run a single shared cluster of it, and then we have a CRD-based operator. So in Kubernetes, we can create a YAML document that will cause a new database to get created in that shared Cockroach cluster, which is more economical and easier to scale. So the last thing that I thought I would just highlight from our story, the TickV and TIDB were relatively recently introduced into CNCF, and it really filled a big gap for us. CockroachDB has been very amazing for us, but we needed the same for this sort of real-time key value caching that traditionally people use Redis. And we had a couple of options. We could have used a managed Redis, but back to my last point earlier, we self-host. We could have run it inside Kubernetes with the Helm chart, but it's relatively challenging to get a high availability Redis cluster when you have 100% preemptible nodes. And we've managed to achieve that with TickV and Titan. So it's been really, really fantastic for us. And that's sort of the architecture there on the right. We have multiple applications that each think they have their own unique Redis. And that's because of when you authenticate to it, it gives you a different namespace in it. And it really has been quite awesome for us. It's very resilient to scaling in and out, and very resilient to temporarily losing a node. And then it provides the same Redis facade that we're all familiar with. So with that, that's all I had to present. If there are any questions, I would love to take them.
Yay, thank you very much, Don, for this great presentation. Actually, we have some questions, actually. First question from Eric. Why do you call it self-hosted instead of self-managed? He has never seen self-host in that context before, and it's usually strictly used. I mean, is it usually strictly used for on-prem?
You may be overreading my words there. I mean what you mean. So we use GKE to manage the nodes, and then everything inside it we manage. So self-hosted, self-managed. I think you know what I mean. I'm not being specific.
Thank you. We have another question from François. He's asking you about the 100% preemptible nodes. Do you see a risk of a possibility that there is a lack of VMs available from the cloud provider? And if you have less nodes in your cluster for some time? If so, how do you mitigate this risk?
So we do that using the node autoscaler in GKE, which has a cost-based rule. So we have one node pool, which is 100% preemptible using N1 style nodes. We have one node pool, which is 100% preemptible using E1 style nodes. And then we have one node pool, which is non-preemptible using N style nodes. That one nominally has 0 scale, and it's used as a node pool of last resort. It will be brought online in the event that there is nothing available from the provider. But yes, there is some risk here, I think.
Thank you. I got another question from Suvro. Is there any reasoning behind not using Helm? Because I think you talked about customized. So I guess the question is why customize instead of Helm?
So a couple reasons. So the first of all, I understand there's been some differences now with Helm 3. Helm 2, I couldn't accept the security model. Going back to I'm assuming that I need zero trust. I need to not have one single point of infinite trust. And Tiller broke that trust with me. And the second problem that I had with Helm, I contributed a bunch of fixes to Helm charts, and the maintainers were just completely overwhelmed. It was not a very good experience. It was many, many, many months. And the third problem I had with Helm is I don't think Jinja is the right tool. I was constantly getting something where I'd end up with invalid YAML out of it because it was a spacing was off by 2 because it was very difficult in Jinja. And I just lost trust in it. Kustomize has worked a lot better for us. It allows us to patch in the behavior we want with the JSON patches. We invented a concept called a K-chart, which is effectively a Git repo for each application, and it behaves like the Helm chart, and then we customize it. And it works better for our GitOps flow, to be honest.
Thank you. We also have another question from Adrian. He's asking if you use OPA directly or if you use OPA gatekeeper. If you don't use the gatekeeper, why doesn't it work for your use cases?
So we don't use gatekeeper. We use OPA as both a library in process in some things. We use OPA as a service. We use it with the authz endpoint of Envoy, and we use it directly integrated with our applications. To be honest, Gatekeeper wasn't around when we started using it, and I have looked at it, but it doesn't seem to meet the needs. It seems to be more, anyway, perhaps I should look at it again, but it didn't seem to be appropriate for us.
Thank you, Dan. Still 2 questions left. What are the major, so it's a question from Arabi. What are the major challenges encountered making Druid cloud native?
Oh my. So Druid at the high level should have been very easy to make cloud native because its architecture is designed to be able to dynamically scale things and out. It has no state other than blob store, which we use GCS for, and relational database, which we use Cockroach for. The main challenge was they'd never built containers for it. And the upstream didn't really seem to believe in the container architecture. So I contributed the Docker file for it. It took a while to get adopted. The second is they were tied to Java 8, which has very poor support for C groups and memory utilization. And the third component was it was very, very difficult to configure. It wasn't native for configuring with environment variables, which is the environment with just the style of Kubernetes. You had all these millions of files in a million spots. And then I guess the last one is it forced us to use Zookeeper and Kafka, which are also challenging to run in a Kubernetes environment. But at the end of it, it works fine.
Okay. I had a very ultimate last question for you from Servo. Do you use Kubernetes Federation to talk between clusters? And that's going to be the last question.
Do I use which to talk between clusters?
Kubernetes Federation.
Oh, no, we do not federate the clusters. There's really not a reason for us to do that. We use Open API and our services between them, but they are each independent from a etcd and deploy standpoint. The only federation is really on the logging with Fluent Bit, I suppose.